Find the volume of the solid obtained by rotating the region bounded by y equals the quantity of x minus 1 squared and y equals x plus 1. This will be rotated about the line y equals 4. We should start with the drawing of the graph. We have two functions. First up, we have this y equals the quantity of x minus 1 squared. This is a parabola that's been transformed. The minus 1 performs a shift of the parabola 1 unit to the right. Take y equals x squared, shift 1 unit to the right. You'll get this guy. So let's do that. Take y equals x squared, shift 1 unit to the right. That'd be the graph of y equals the quantity of x minus 1 squared. We're just sketching for now. Then we have y equals x plus 1. That's a line with the slope of 1 and the y-intercept of 1. Well, great. So this is going to be rotated about the line y equals 4. So we'll just label that. And in order to really solve this problem, what we need to find are these points where the two functions intersect each other. Well, how do we do that? We set them equal to each other. So take the left-hand side and multiply it out and get x squared minus 2x plus 1. Then subtract over the x, subtract over the 1 to have everything set equal to 0, and you end up with these 1's canceling each other out. And you get x squared minus 3x equals to 0. Factor out the x, you have x times the quantity of x minus 3, and so either x is 0 or x is 3. So we have 0 here, of course, my drawing shows it, and then 3 is the other place where they intersect. Okay, we're ready. The second step will be to decide which method to choose. So my recommendation is to have two drawings of the graph. One where you draw a rectangle that's parallel to the axis of rotation. One where you draw a rectangle that's perpendicular to the axis of rotation. The parallel rectangle is shell method. The perpendicular rectangle is disc or washer, based on whether there's a gap between your region and your axis, and yes, we do have a gap. Okay. So when you have a rectangle that's laying on its side, it gets moved upward. And so what that's going to accomplish then is to say basically that the shell method will be in y. Y is changing. When you have a rectangle that's upright, it gets moved from left to right. Well, that means it's in x. So we have the two methods, shell and washer, and we have to decide which one to use. Nothing looks apparent from what we have, but we have to be careful. If you look to an earlier rectangle, you'll see a problem. This rectangle causes a problem. Here's the problem. If you ever have one of these rectangles where both the left and the right hand side of your rectangle happen to appear on the same function, then when it comes time to find the height of that rectangle or how long that rectangle is, they'll cancel each other out. So because these guys are on the same function, then we cannot do this method. Shell method is out. So let's do washer. So we have the washer method, it's in x. We have a rectangle that's perpendicular to the axis, and we know the formula is outer radius squared minus inner radius squared. Then we integrate. So what we need is the outer radius. The outer radius is a line that goes from the axis of rotation through the region to the end of the rectangle. In this one, we have an orange line to represent that. Well, that is one distance subtracted from another distance. We have this distance of 4, which is the distance down to the x-axis. From that distance, we have to subtract this distance up from the x-axis. Okay, this distance up from the x-axis will be always called y, but it's the y for the parabola. the equation of the parabola is x minus 1 quantity squared. So we take 4 and we subtract that vertical distance upward to the parabola, and that will be our outer radius. Square it out, and then combine the terms. So we have squaring it out, we get x squared minus 2x plus 1, and the 4 and the 1 combine to give us a 3. And writing them in decreasing order, we have a negative x squared and a positive 2x and a positive 3. That is our outer radius. Now let's go for our inner radius. It's a line from the axis of rotation that comes up just to the region, or just to the rectangle. This distance here is the inner radius. Once again, it's a subtraction of one distance from another. We take this distance 4 again, and from it we subtract the distance up to the line. So it's the y value off the x-axis for the line. And the line's equation was x plus 1. Combining the terms, you get 3 minus x. So we have our outer radius, we have our inner radius. Now we're ready to go attack the formula where we square them each, subtract, and then integrate. Okay, great. So let's square. Usually this is trouble, squaring a trinomial. Let's see what we can do. I want you to picture it as being that what you're doing is sort of foiling out. Multiplying negative x squared times all 3 of these terms. And then we'll also square out 3 minus x. Multiplying negative x squared times the 3 terms that we have on the right set of parentheses, we get a negative times a negative is a positive, so x to the 4th. Then we get a negative 2x cubed, because x squared and x. And then we get a negative 3x squared. Next, we move to the 2x, and we multiply it by all 3 of these guys. 2x times a negative x squared is a negative 2x cubed. 2x times a 2x is a 4x squared. 2x times a 3 is a 6x. And when you write it, think of these are like columns. These are your 4th degree terms, these are your cube terms, here go your square terms, here go your x terms. If there's a constant, they'll end up here. That way it makes it easier for you to combine the terms. Finally, we multiply the 3 out. We get a negative 3x squared, a positive 6x, and a positive 9, and we combine vertically to give us our x to the 4th, our negative 4x cubed. These guys here combine. You have a negative 6 and a positive 4, so they combine to be a negative 2x squared, positive 12x, and a positive 9. That is the squaring of the outer radius. Moving on to the inner radius, just FOIL this out. We get a 9 minus a 3x minus another 3x to a grand total of minus 6x, and then a positive x squared because it's a negative times a negative. So we have the outer radius squared, and now we have the inner radius squared. What are we supposed to do with these guys? We are supposed to subtract. Now we want to simplify this before we go to integrate. Well, how does it simplify? Well, not too many terms are the same. It is nice that they have these 9s here. We have a 9 minus a 9. Those guys cancel out. So putting it all together, outer radius squared minus inner radius squared, we have our 4th degree x to the 4th, our cubic minus 4x cubed. Then we can combine these x squared terms. Watch the sign here though. That's a minus 3x squared. And then 12x minus a negative 6x is a positive 18x. And those are our 4 terms. These are the guys that end up in our integral. These are the guys we have to find the antiderivative of. And remember, it's from 0 to 3. Why 0 to 3? Because if you go back to the first slide, remember the limits of integration ended up being you go from some low of x equals 0 to some high of x equals 3. Okay, great. And pi. The volume washer formula by the volume washer formula has the pi outside. Pi is basically an inner disk subtracted away from an outer disk. All right, great. Let's work this out. Well, antiderivative of each, x to the 5th over 5. Now watch this. This will be minus x of minus 4, x to the 4th over 4. And those 4s will cancel. This will be minus 3, x to the 3 over 3. And the 3s will cancel. This will be 18x squared over 2. And that'll make it a 9x squared. Now, fundamental theorem of calculus says you plug a 3 in, get a value. Plug a 0 in, get a value. And you subtract the one from the other. But, of course, plugging in 0 will give you 0. Here's my recommendation. We have a 3 to the 5th, and a 3 to the 4th, and a 3 cubed, and a 9 times 3 squared. I kind of overdo it, but I think it's good to write it out like this first before you expand the powers out. Okay, 3 to the 5th is, if you need to, I mean, you don't have a calculator, I would do it like this, where I do 9 and 9, that's 81, and then 81 times 3 is 243. And then we have a minus an 81. Be careful here. You take it to the 4th, and then you subtract. This is plus 81 because it's 9 times 9. And those guys cancel each other out. And then here we have a minus of 27. Once again, the minus applies afterwards. So it's our job to take 243 over 5 and subtract 27. So you don't have a calculator. If you need to, just scratch it out, where we take and multiply 27 times 5, and we get 135, and we need to take 243 and subtract 135 from it, and we get 108. Final answer, 108 pi over 5.